Welcome back. How was this exercise? Hopefully it wasn't too difficult. If you're able to answer these questions, you're most likely going to be okay in an interview if you ever get asked about depthFirstSearch or breadthFirstSearch. So let's go over the answers. If you know a solution is not far from the root of the tree, well, we talked about this. We want to use breadthFirstSearch because it starts searching the closest nodes to the parent first. If the tree is very deep and solutions are rare, well, this is a bit of a tougher question, but we would use breadthFirstSearch. And the reason we would do that over something like depthFirstSearch is that depthFirstSearch will take a really long time with this type of a tree. Because the tree is really deep, it's going to go one by one, going really, really down below. And because solutions are rare, it's most likely going to just repeat that step over and over and over. And as you'll see with depthFirstSearch, we use recursive functions. And with depthFirstSearch, that can take a really, really long time. Although with this one, we also have some memory concerns with breadthFirstSearch. So your answers may vary, but this is what I would use. As long as you can explain that to the interviewer, you're fine though. What if the tree is very wide? That is, there's a lot of nodes. It's not a binary tree, it just has a ton of nodes underneath each parent. Again, this is a bit of a tougher one, but we want to use depthFirstSearch. Because a breadthFirstSearch, and I'm going to say BFS from now, is, well, it's going to need too much memory. The way breadthFirstSearch works is that it has to keep track of the nodes in the current level in something called a queue that we will see. So because of that, it might take up too much memory. What about the next one? If the solutions are frequent but located deep in the tree? Well, in that case, we'd use depthFirstSearch. So hopefully we'll be able to find an answer quicker than breadthFirstSearch. What about the next one? Determining whether a path exists between two nodes. That is what depthFirstSearch is built for. What about finding the shortest path? That is for breadthFirstSearch. Now, keep this document in mind and revisit it as we learn more and more about these two algorithms, because things are going to start making sense more and more. But this is a good sheet to keep in mind before you go to an interview in case you get asked these questions. Enough talking for now. I think it's time for us to start coding these algorithms. I'll see you in the next one. Bye-bye.